Now, the big idea in Big O is that we want to see what function family our code is in and think about how we can make it faster. Now, we only care about the large n because, as I said before, in small n's, first of all, it's not a good way to compare, but second of all, no matter what function family your function is in, on a small n, most modern computers are going to be able to do that relatively fast. For instance, even an exponential function, if you give it an input of size 10 or 20, it's still going to be able to do it fast enough. However, when we talk about big N's, that's when we start to actually see how fast our function runs. Again, as we said before, the constants don't matter because as we saw in the graph above, when the constants, as we increase the size of our n, the function family class starts to dominate and the constants fall away. Now, how do we actually use the idea of big O when writing code? Now, what it means is that, as we said, trying to make your function faster with constants is not going to help. For instance, in my example where I try and get the number of elements in a list, def count of L, I do for I in range L, count plus equals 1, return count. And I initialize my count to 0. Now, let's say that I did the thing where I say that lm is equal to L of I. Now, this function right now does two operations for each of the n elements in L. So it has a function of 2n. However, I could optimize it by removing line 4 because that's unnecessary. So I would go from 2n to n. However, when we look at the big O, I just went from O of n to O of n. So in practical terms, I didn't actually speed up my function because asymptotically it would still be the same because 2n and n asymptotically converge onto the same work path. If I wanted to make it completely faster, then I could simply change big O function families by calling return len of L because it's actually constant time to get the length of a list given that list. So now instead I went from 2n to n to constant, which means that in terms of my big O, I went from O of n to O of 1. Now this is an actual speed up. And so when you're writing your code, you want to look for how can I algorithmically change my function so that it actually changes the function family class. This will allow you to gain tons of speed much more effectively than if you tried to change constants. So, the moral of the story is to think algorithmically.